A phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. So given a string S, return true if it's a palindrome or false if otherwise. So what is a palindrome? It's just a string that reads the same forwards as backwards. Um, so uh, and in the context of this problem, they want us to exclude, there's some edge cases, right, that we need to just ignore. So they want us to ignore non-alphanumeric characters. They want us to also ignore differences in case. So two kind of things to consider there outside of the just the palindrome comparison. So yeah, let's whiteboard this. It's pretty straightforward. We can use 2 pointers to solve this with the big O of n, time complexity, where n is going to be the number of characters in the string, just the length of that string, for a single pass, and then with our 2 pointers. And for the space complexity, it's just going to be constant, so big O of 1, because we're not going to be using any extra data structures. That's scale, right, with the inputs to this method, right, for the problem. So let's look at an example. So we'll do race car, but I'll throw in some weirdness. Okay, so that is our input, and we're just going to have a left pointer, and we're going to have a right pointer. And we're basically going to have a loop. We're going to iterate while our right pointer is greater than our left pointer. So just as long as our pointers aren't overlapping, we want to continue to compare the characters that are marked by those pointers. So before we do any comparison, we're going to skip over any character that isn't alphanumeric. So that's first. Second, we want to convert the character to just a standard case. That way, when we do the comparison, we ignore the difference in case. So for that purpose, we could just convert both characters to lowercase and then do the comparison, right? Or to uppercase works, doesn't matter. So for these two, they're both alphanumeric, but they're different cases. But we're not even going to check what case if they're different. We're just going to both set them both to lowercase. Okay, they're going to be the same at that point. So then we don't exit the loop. If any of our conditions are violated, we'll just exit the loop and return false, right? Otherwise, we'll continue looping and then like return true at the very end of the validation, like pass through, right? So this is a semicolon. It's not alphanumeric, so we need to skip it. Okay, we're at 2 alphanumeric characters. We're going to convert them to lowercase. The lowercase a's will be the same. So we will increment the left pointer, decrement the right pointer. Both alphanumeric converted to lowercase, these c's are the same. So increment the left pointer, decrement the right pointer. This is not alphanumeric, so increment the left pointer. And notice how for odd palindromes, if we, in our conditions, we don't want to say, we basically want to stop, or we want to continue looping as long as the right pointer is greater than the left pointer, right? We don't want to stop prematurely, basically, for this case where we have an odd length palindrome. It's okay that they're overlapping because we don't want to have like a bunch of like different cases for an odd length palindrome and an even length palindrome. That would make the code really messy. So if we just loop while the right pointer is greater than the left pointer, we can handle these odd length palindromes by having these overlapping. And when we do the check, we can actually just compare the same character with itself on the last iteration, increment the left pointer, decrement the right pointer, the next iteration won't even run. So yeah, that's pretty much it for the algorithm. Hopefully what I just explained at the end there makes sense. It might not yet, but it should. But it should after I get the code down. So we're going to have a left pointer and a right pointer. We can set the right pointer to the last index in the string. So we'll say s.length -1. Okay, and then we're going to just loop while the left pointer, or while the right pointer is greater than the left pointer, right? And then we're going to skip over all of the characters that aren't alphanumeric, right, for both pointers. So we'll say we want to make sure the right pointer stays greater than the left pointer, but otherwise we just want to check, right, is it alphanumeric? So is al_num, that's the method in C++ for checking if a character is alphanumeric. So we're going to do that on s at L. If it is not alphanumeric, then we can just increment the left pointer to skip over that character. And we need to do this exact same thing with the right pointer. So we can just copy this over, and maybe more cleanly this could be like a method, but or something like that, but I'll just do this to keep this kind of short. So that's skipping over those. And then before we do the comparison, we want to convert both of these characters to lower. So we'll say if toLower s at L is not equal to toLower s at R, right, then those characters are a mismatch, right, disregarding the case. So we have to return false. Otherwise, we can continue. So we will increment the left, decrement the right for the next iteration. At the end of this, if we never return false, then we know we have a valid palindrome, so we can return true. And that's pretty much it for the problem. That should handle both even and odd length palindromes. So yeah, hopefully this helps, and see ya. Peace.